For this standard, I manage the use of technology and student learning strategies in digital platforms, virtual environments, hands on maker spaces, or in the field. For this standard, I utilize technology to engage second grade students in a non traditional classroom setting as we work together in the library. We transformed a cardboard frog robot and programmed it using the Microbit platform. Throughout the project, we embraced the creative play design process, nurturing imagination, collaboration, and sharing. By employing block coding, the students gained proficiency in computational thinking and pattern recognition. I effectively manage the utilization of technology, ensuring its seamless integration into our digital platforms and virtual environments. Additionally, I establish clear expectations for behavior and responsible use of technology. This immersive, technology driven experience not only enriched their learning, but also fostered the development of coding skills and collaboration, both in our hands on makerspace and during our field explorations. In my creative computing project, I kept my second grade learners engaged and on task in a non traditional setting, such as the school library versus the classroom. Through the steps of the creative play design process, we inspired their imagination with a frog robot, imagined a cat robot, created it collaboratively, programmed it with Microbit, played with it by activating its movements, and planned to share it with the class. The process fostered computational thinking, skills, and hands on engagement. In our non traditional learning environment, I set clear expectations for technology use based on our school rules. Students are expected to respect others, work and play safely, and show kindness. If students fail to follow these rules, they will be replaced by other students in the project. These expectations apply in various settings, such as the makerspace, outdoor classroom, or small group sessions. In this artifact, I create learning opportunities that challenge students to use a design process and computational thinking to innovate and solve problems. For this standard, my learners were second grade students in a co-taught classroom at an elementary school in DeKalb County, Georgia. In my creative computing project, I challenged my students to use a design process and computational thinking to innovate and solve problems. We transformed a frog robot into a cat robot following a 5 step design process: inspire, imagine, create, play, and share. Through collaborative discussions and sketching, we envisioned the new robot. Working together, we built the cat robot and modified the code using the Microbit MakeCode platform. I guided the students in decomposing the code, recognizing patterns, and troubleshooting. They applied computational thinking skills like abstraction and pattern recognition. The project provided challenging learning opportunities for them to apply the design process, problem solve, and practice computational thinking by building and programming the new robot. In the future, I plan to expand the project, providing more opportunities for students to apply these skills. In my creative computing project, students applied computational thinking skills like decomposition and pattern recognition. They programmed the microbit, debugged code, and used the simulator to adjust their creations. I suggested expanding the project for a better learning experience. It integrated design and computational thinking, promoting engagement and problem solving. In the creative computing project, I guided my students through the design process and computational thinking. We explored the frog robot, imagined and created a cat robot. I taught them code modification using computational thinking skills. They built the robot, adjusted the code, and observed the results. The project showcased their engagement and computational thinking. In this standard, I model and nurture creativity and creative expression to communicate ideas, knowledge, or connections. I focused on modeling and nurturing creativity and creative expression within my own classroom. I demonstrated my own creativity by presenting a robotic frog I had created as part of a graduate level class. I shared my problem solving experiences, including addressing issues with the frog robot's functionality. I provided opportunities for students to express their creativity through collaborative design and programming of their own robotic pet. I facilitated sharing of students' work through recorded Zoom presentations, allowing for asynchronous feedback. I encouraged peer communication of ideas, knowledge, and connections. Through synchronous Zoom sessions and the use of the Flipgrid platform, I utilized various technology resources, such as the Microbit Kit, MakeCode Simulator, and craft materials to support and enhance students' creativity throughout the project. I focused on modeling and nurturing creativity when implementing this project. I demonstrated my own creativity by designing a robotic frog and shared my problem-solving experiences. I provided opportunities for students to creatively design their own robotic pets, facilitating sharing through Zoom presentations and encouraging peer feedback.